Okay. Like I said, for those of you that are at home, the notes for today are in the folder. This is 6-1 day 2, and we're talking about what's called a composition of functions. All right. You might have heard this term before. It is a little involved just with the very beginning. Once you get into the habit of what you need to be able to do, it gets a little bit easier. But let's make sure that we keep like a really solid focus, at least in the beginning, so we can kind of grasp what we're doing here with our composition of functions. Okay. Essentially, what we're doing is what's called mapping. So you're taking like x values of one function, seeing what the output is, so seeing what the y value is. Then you're going to take that y value and plug it in for x in a separate function and see what that y value gives you. All right. So there's a couple notes here in the beginning that are pretty much outlining that idea. But I think the best way for us to go about this is to kind of just look at an example and see how we can apply that to what we're going to be learning today. All right. There's two separate ways to find composition of functions, or at least what you're going to see. You're either going to be given a function and its points, so its values. If you plug in x for this function, you get these y values, right? These coordinates. You could also be given the function itself, like we saw yesterday. So you might be given like a 2x plus 2 or a negative 3x squared minus 9, whatever it might be. We'll kind of get to that towards the end of class, and we'll see how we can find a composition of functions that way. But for right now, we're just going to be dealing with points of a function. Okay. One thing that we're going to be able to find off of this is the domain and range. Remember that your domain is all of the x values that you plug into a function. Your range is all of the y values that are then your output of that function. All right. So something to kind of keep in mind as we progress through this lesson. As I said before, what we're finding here, so we're going to use this example. For each pair of functions, we're going to find this is f of g of x. So that's how you would read that. Okay. Just some more symbols for us to work with. F of g of x and g of f of x. Okay. What this means, f of g of x, we're going to take all of the x values from g of x, find their input, and plug them in for x in the f of x function. G of f of x is just the opposite. So you're going to take the y values of f of x, plug them in for x in the g of x function. I know it sounds like alphabet soup because I'm saying a g of x and this, that, and the other thing, but when we go through examples, it'll be a little bit easier to follow. Yes. Sure. Okay. We're going to use this note above to help us start the first question with finding f of g of x. Okay. What we do is we go to whatever the value is for g. So we always start from the inside out. Okay. So g of 8, what that means is wherever 8 is for x, I'm going to find the y value. Okay. Well, if I look at my list here, g of 8 is 15. Do we see that? So when we plug in 8 for x in the g function, we get 15 out. All right. I'm going to take that 15 and I'm going to plug it in for x in the f of x function. So you see this note, if you follow along here, g of 8 is 15. Since we have the ordered pair 8, 15, we'll take the 15, plug it in for x in the f of x values. So now I'm going to look for 15 in my f of x, wherever it is in x. And what's the y value for 15 in f of x? 11. So when I kind of circle back around, g of 8 was 15, f of 15 was 11, so f of g of 8 is 11. That is the composition of functions. Okay. I know it's a lot to work with. It is a lot, right? Did you take geometry before algebra 2? Do you remember the transitive property? Probably not, right? It's like if this equals this and this equals this, then this equals this, like A, B, B, C, then A, C. It's literally the same thing. You're just applying it to algebra. Okay. I love geometry. That's my favorite. Let's see how we can apply this to the other x values in the g function. Okay. So what you're doing is when you're listing your composition functions, you're taking all the x values, working with those, and then finding the y values in the other list there. Okay. So g of 5. No. That's where you're going to start with the inside. So if I look back to my list on the previous page, g of 5 is 1 from the ordered pair 5, 1. So what I would start doing is just writing down g of 5 or whatever that inside value is and writing what the y value is. And then you're going to take that 1 and plug it into your f of x function. When I do that, then I'll go back to my list. F of 1 is what y value? What's the y value for f of 1? 8. What's that? Right, that's all we're doing right now. So then f of g of 5, so when we plug in 5 to that composition, we get 8.
So you know how we have to go back to this page?
Yeah.
Is this like the universal numbers for all problems?
No. You'll get different numbers for each problem. Good question, though. We'll just do the same thing for each x value in our g of x function. So now I'll go to g of 10. So what's g of 10? Right, good. So I look for wherever 10 is in my x, 14 is my y. And then I'll take that 14 and I'll plug it into the f function. And what's f of 14? 9. So then f of g of 10 is 9. Excuse me.
Are you always going to be able to find the numbers?
No. So we'll see an example in a little bit where that's not the case. Good question, though. Good foreshadowing. Question? Right, so you take the g of whatever's on the inside, that's where you start. And then your answer will be whatever the y value is from the outside function. Okay? So all of your answers should be a y value from f, essentially. Really good point. What's g of 9 if you look back to the first page? 0. Good. So g of 9 is 0 from that ordered pair. So then I'll do f of 0. And if I look back on that first page, what's f of 0? 13. So f of g of 9 is 13. Does everybody follow each of those examples? We understand the process of what we're doing. Pretty good? Okay. Well, just like we can find f of g of x, we can do the opposite and find g of f of x. So now instead of starting with my x values in g, I'll start with my x values in f. All right. The process is the same though. So I go to f of 1 to start, right? That's the inside of my function. Well, if I'm looking at my list, what's f of 1? 8, right? It's whatever the y value is for 1 as an x value in your f function. So f of 1 is 8. I'll take that 8 and plug it in to the g function. If I'm looking at my list, what is g of 8? 15. So then g of f of 1 is 15. Question? Just the y. So you're looking for the output of that composition. Output's always like going to be a y value. Any questions about that first example? F of 0. What's f of 0? 13. Good. We get it from that ordered pair there. What is g of 13? There's not a 13 in the x values for g, right? If I look across my x values, I have 8, 5, 10, and 9. I don't see a 13. When that is the case, when you don't have, so Emma, to your question from earlier, when you don't have a x value in your function, we say that this is undefined. Nah. You just say that it is undefined. What's that? That is the answer. It's just undefined. Let's go to the next one. F of 15. What's f of 15 to start? 11 from that ordered pair. What's g of 11? Undefined. Good. So if I look at my list, there is no 11 in for x. So g of 11 is then undefined. Okay. Any questions about either of those last two examples? We understand why something would be undefined. Let's go to f of 14. What is f of 14? 9. G of 9 is 0. So then g of f of 14 is 0. Any questions about finding any of our values there for the g of f of x function or composition? Okay. One thing that we're going to get into now is listing our domain and range for each of these functions. Okay. Remember, the domain is your x values that you plugged into the composition. Okay. So we're dealing with the domain and range of the entire composition, not just the f function or the g function, but the whole composition. So your x is your domain, your y values or your output is the range, the output again of the entire composition. So if I look back on the first page, when I plugged in 8 for f of g of 8, I got 11. So 8 would be in my domain, 11 would be in my range. And that's what we see here. So 8's in my domain, 11's in my range. When I went through and solved all of these, f of g of 5, well, 5's in my domain. 8 was the output, so 8 would be in my range. F of g of 10, 10 was something that I plugged into my domain. 9 was the output, so that's in my range. And then f of g of 9, again, 9 something that I plugged in, 13 was in my range. Your input or your domain, your x values, are going to be the x values of the inside of your parentheses. So notice that all of the g values, the 8, 5, 10, and 9, they're all in my g function. They're all in my domain of the composition, right? That's where I start. The output is totally different. So make sure that you understand your domain and your range aren't necessarily going to be for one function, but the whole composition. When I'm listing the domain and range for my g of f of x, so the last example that we just did, you're only going to put in values that gave you an output. So whenever you have an undefined, you don't list the x's in your domain, you don't list the y's in your range. So for that reason, notice that when I plugged in 1, I got 15. So 1 and 15 should end up in my domain and range, respectively. But when I plugged in 0, I got undefined. So 0 doesn't go in my domain, and there's no thing that I could put in my range because it was undefined. Same thing with 15. When I plugged in 15, I got undefined. So 15 shouldn't show up in my domain, and there's nothing I can put in my range. When I plugged in 14, I got 0. So when I got the value, when I plugged in 14, I write that range, or write that value in my range. Okay. Any questions about domain and range and how we would list that? Okay. We're going to do another example. We're not going to find both compositions. So we're actually just going to find the g of f of x here. So if you want to cross off that first composition, that's fine. We're going to go through and do the same process as we did before. All right. So you can start each problem here if you're doing composition of functions. You can start by writing all the x values for the inside function there. So you're going to find g of f of -8, because that's the x value in f. You're going to find g of f of 0, g of f of 2, and g of f of -6. So like I said before, your input, your x values are going to be all the x values from the inside function. So my inside function right now is f. So I'm going to plug in all the x values from my f function. Do we follow that?
Are these numbers from?
No, they're from these functions listed right above. So f equals and g equals, those are two different functions now. Okay. 1 second here. So when I'm looking at my list of values there, what is f of -8? Because I'm going to start with the inside function. -4, right? -8, I get -4. So then I'm going to take that -4 and I'm going to plug it into my g function. Well, what's g of -4? 0. I just go to wherever that x value is, -4, see if there's a y value, and I have 0. So then g of f of -8 is 0. Keep going through the same process. What's f of 0? What's g of 4? So then g of f of 0 is -4. Any questions about how we found the values for the first two? Well, it's f of 2. So if I look across my value for f, I have 2. The y value is 6. I take that 6 and I look for g of 6. Well, if I look across my table, what's the y value for g of 6? -5. So then g of f of 2 is -5. start on the inside again. What's f of -6? So if I look across my f of x, I see -6. What's the y value? -2. Take the -2 and plug that in to the other function. So g of -2 is what value? -1. So then g of f of -6 is -1. Okay. Any questions about how we found any of those values? Now what we want to do is state our domain and range. Remember, our domain is all of the x values, excuse me, all the x values that we plugged in to the original composition. So what were the x values that I started off plugging in? Good. So all of these values in the beginning, -8. Yeah. -8, -6, 0, and 2. Write them in numerical order. So from least to greatest. -8, -6, 0, and 2, all the values that I plugged in for x in the original composition. And then my range is the output, so all of my answers. So if you're listing your range, how would you list that? -5, -4, -1, and 0. Bless you. Okay. Any questions about that example? Like I said, we're not going to find the f of g of x, but any questions about how we found the values or listing the domain and range? Okay. The other type of example that you will see might be a little bit easier since it's a little bit more algebraic. It's not necessarily just following, numbers around. Is when you're given legitimate functions to work with, okay? And when we get a problem like this where they tell us f of x is 2x minus 5, g of x is 4x, what we do is we take the entire function that we see and we plug it in wherever we see the variable in our other function. All right. What I mean by that is if we're going to find f of g of x, start by writing down the outer function. So your f of x is 2x minus 5. And then what you're doing is wherever you see an x, you're plugging in the entire function g of x. So I have 2 times x. Wherever I see an x now, I'm going to plug in the 4x because that's the entire g of x function. And the -5 just tags along on the outside. So the function itself doesn't necessarily change. It's just what you plug in for x changes. Everybody follow that? And then we simplify the same way we would before. So what's 2 times 4x? 8x. I have 8x minus 5 for my answer for f of g of x. It's a little bit easier to work with, maybe, than mapping different values and points and stuff like that. Can do the same thing for g of f of x. G of x is 4x. So now wherever I see an x, I'm going to plug in the entire function f of x, because that's what's on the inside of my parentheses there. So I'm going to do 4 times, instead of x, 4 times 2x minus 5, the whole function. What do I have to do with this 4 and the 2 terms inside my parentheses? Distribute. And what happens when I distribute? Good. So g of f of x is equal to 8x minus 20. Okay. Any questions about that first example? Do you think this is easier than what we were doing before? It's kind of the same, equally boring. So we'll do the same thing with this next example. I have f of x is x squared plus 2, g of x is x minus 6. We want to find both composition of functions. Okay. So f of g of x, I'll write down my original f of x equation, which is x squared plus 2. And now wherever I see an x, I'm plugging in x minus 6. So be careful, because it's x squared. That doesn't change what you're going to do. So you'll have x minus 6, that whole thing, squared plus 2. You're only plugging in the function where you see an x, right? Doesn't substitute with x squared, just x. Does everybody follow that? So then you do x minus 6 squared. Does everybody know the trick for how you can do that without having the FOIL out and everything? Do you remember it at all? You square the first term, so what's x times x? You do 2 times the product of both terms. Well, what's negative 6 times x? What's that? What's negative 6 times x? Negative 6x, right? And then 2 times that would be negative 12x. And then you square the second term. What's negative 6 times negative 6? Positive 36. So you don't have to break it apart and then FOIL it and then combine like terms if you remember that rule. So the first term squared, 2 times the product of both terms, the second term squared. Still have the plus 2 on the outside. When I combine like terms, what would my final answer be? Good. So f of g of x is x squared plus 12x, or minus 12x, excuse me, plus 38. Okay. Any questions about the first composition of functions? find g of f of x. So again, I'll write my outer function this time, which is x minus 6. And now wherever I see an x, what am I plugging in? Good. X squared plus 2. When I combine like terms, what do I get? So hold on. I have x squared plus 2 minus 6. That's all right. X squared minus 4. So g of f of x is x squared minus 4. Okay. Any questions about either of those two examples there using composition of functions or anything that we discussed today? Okay. Your homework for tonight. So if you go into the folder for today, page 390, you're doing 21 through 35 odd. Okay. For 21, 23, and 25, let's do just find the f of g of x. All right. You don't have to find both compositions because that is a lengthy process. So just find f of g of x for each of those, and then state the domain and range. 27, 29, 31, 33, and 35, find both because that's a little bit easier of a process or not as lengthy as a process. And that's when you're plugging in each function wherever you see an x. Okay. So you're doing page 390, 21 through 35. For 21, 23, and 25, just find f of g of x. So just the one composition, not both. State the domain and range. For 27, 29, 31, 33, and 35, find both composition of functions. Okay. Any questions about the homework assignment? Okay, please make sure that you get that done. When you come in tomorrow, we're going to go over that, and then we're going to review these concepts from today. So we'll work on some problems with mapping, like we saw in the beginning, and then some problems with actually plugging in functions inside of functions, okay?